In the figure above, PQRS is a rectangle, so that lets us know that these are right angles right over there. The area of triangle RST is 7, so RST is 7. And PT is equal to 2/5 PS. What is the area of triangle PQRS? So let's think about what information they've given us and what we need to figure out. So they tell us the area of triangle RST is 7. So what is the area of triangle RST given these lengths right over here? Well, triangle RST, the area of any triangle is 1/2 times the base times the height. So what is the base of RST? Well, we could view it as the length of segment ST. So the area is going to be equal to 1/2 times the length of segment ST times the length of segment ST, I'll put that in parentheses, times the height, which is the length of segment RS. So times RS, and that's equal to 7. That's equal to 7. And if we wanted to simplify this a little bit, we could multiply both sides by 2. And so we could get the length of segment ST times the length of segment RS is equal to 14. Just multiplied both sides by 2. 2 times 1/2 is 1. 2 times 7 is 14. So this first piece of information is that the product of ST and RS is 14. Then they tell us that PT, I'll do PT in orange, then they tell us that PT is equal to 2/5 times PS. And let's just say let me use pink I'll just use this dark blue for PS. Times PS. So that's that length right over there. That's PS. 2/5 times PS. So that's the second piece of information right over here. I just rewrote it. And now what do we need to figure out? We need the area of PQRS of this entire rectangle. Well, the area of a rectangle is just going to be its base times its height. So the area, what we need to figure out, is going to be PS, the length of segment PS. So I could write, so we need to figure out PS times the height, which is RS, times RS. This is what we need to figure out. So going back to what we know, so here we know PT in terms of PS, or PS in terms of PT. Here we have an expression with ST, RS, and 14. So somehow if I could turn this ST part of this expression, if I could turn this into something that deals with PS, then I'm going to be in pretty good shape. Now let's just look at this. How does ST relate to PS? So let me write this over here. So the length of segment ST is equal to the length of segment PS. It's equal to the length of segment PS minus the length of segment PT. Minus the length of segment PT. So I could substitute this in for ST, but then I would have something that's in terms of both PS and PT. But lucky for us, we can also substitute out the PT for something in terms of PS. That's what this does right over here. So this, we know that PT, the second piece of information they've given us, PT is equal to 2/5 PS. So we can rewrite this whole thing as saying ST, the length of segment ST, is equal to the length of segment PS minus 2/5 times the length of segment PS. Minus 2/5 times the length of segment PS. And once again, how did I do that? Well, we know that that is equivalent to that from this piece of information, here. And what's powerful about this is now I have ST purely in terms of PS. So if I were to replace ST with what I have in terms of PS, it looks like I'm going to have some type of product of PS and RS, or something that I can solve for the product of PS and RS. But before I even do that, let's simplify this a little bit. If I have 1 PS minus 2/5 PS, or we could even say if I have 5/5 PS minus 2/5 PS, we get ST is equal to 3/5 times PS. And now we are ready to substitute. So instead of having an ST here, we could write 3/5 PS, 3/5 PS times the length of segment RS, these are all the 3/5 times the length of segment PS times the length of segment RS is equal to 14. And now we could just solve for this product. What is PS times RS? Well, let's just multiply both sides times the reciprocal of 3/5 times 5/3. And we get, and I think we deserve a drum roll now, we get the product of PS and RS being equal to, let's see, what's 14 times 5? It's going to be 50 plus 20. It's going to be 70. So this is going to be equal to 70/3. And we are done.